Hello, eighth grade. We're going to continue working with exponents today. So I want to go back to thinking about what we talked about last week with zero exponents and negative exponents. So let's understand why x to the negative first power is equal to 1 divided by x. And if you remember, we looked at patterns that involved decreasing an exponent by 1, and then what happens to the value of that. So here we're using a base of x, but it could be a base of anything. It doesn't really matter. So x squared means x times x, right? X to the first power means just a single x. And now if you think about how do we go from here to here? Well, we took x squared, we divided it by an x to get a single x. And if we do it again, we divide this by x, x divided by x is 1. And we said last week, anything raised to the 0 power has a value of 1. So then what happens if we divide by x again? Because we continue this pattern of decreasing the exponent by 1. Well, it is exactly what it sounds like, 1 divided by x. Then what happens if we do that again? Well, now we're going to divide this by x, and we get 1 divided by x squared. So there, that pattern continues on forever. So now what happens if the negative exponent is in the denominator? So now we need to think about division. And I'm going to write this problem a little bit differently. This problem is read 1 divided by x to the negative first power. What if I wrote it this way? 1 divided by x to the negative first power. Well, now we have this negative exponent here that I could write differently. We know that x to the negative first power is the same as 1 divided by x. So now I have 1 divided by 1 divided by x. Seems kind of weird, doesn't it? Well, let's go back to dealing with fractions. When we divide fractions, we rewrite them as multiplication problems. So we're going to rewrite this as a multiplication problem. 1 times the reciprocal of 1 divided by x. And reciprocal is any quantity that you just flip the numerator and denominator. So if you flip this, it becomes x over 1, which is the same as x. 1 times x is x. So this 1 divided by x to the negative first power is the same as just saying x. So we're going to practice with that a little bit more. And that will make more sense after a little bit. Okay? All right. So I'm actually going to come back to this problem. What if we wanted to find the value of this expression? This is 3 times 10 to the negative second power. Now you might remember in 5th grade, we actually did some problems like this. So we need to think about the value of 10 to the negative second power. And we know that anytime you have a negative exponent, it means that we have been dividing by that base. So if we know that 10 to the first power is equal to 10, 10 to the 0 power is equal to 1, 10 to the negative 1 power is 1 divided by 10, and then 10 to the negative 2 power is 1 divided by 10 squared, which is 100. So there is a pattern happening here. I'm going to add 10 squared up here. And do you see this pattern? Do you see what happens? If this is sort of like the starting point, if we go up 1 exponent, we have 10, and if we go down, we have 1/10. If we go up, we have 100, and if we go down, we have 100th. Okay, so this 10 to the negative second power is the same as 100th. And so 3 100ths would look like this, or you could write it in decimal form. So that would be the value of 3 times 10 to the negative second power. All right, what about 3 times 10 to the negative 5th power? Do you think that you could do that just based on patterns? Well, we know that this is going to be in the denominator, right? This 10 to the 5th power. So you could write it this way, but then you could think about what is 10 to the 5th power? This would be 3 over 10 to the 5th power, which would be 100,000. So that is 3 100,000ths, which could also be written in decimal form, but not very pretty. what about 5 to the negative third power? Again, the patterning is always the same. We could write this as 1 over 5 cubed. And again, you might be able to see that this was this, right? We know that any quantity can be written as a fraction if you put it over 1. This becomes this. Interesting. Do you think that's going to be helpful? It might. All right, what about 1 over 8 ninths? 8 to the ninth power, I should say. 1 over 8 to the ninth power. 1 divided by 8 to the ninth power. Now, we want to write this a different way. We want to go find another way to write this. And if you follow the patterns that we've been doing, we started with negative exponents that ended up in the denominator. So what if we have a positive exponent in the denominator? Well, we could write that as a negative exponent, right? Because following that pattern, this would be kind of like this. Do you see that it's positive here and negative here? Just like when we did that previous problem or something like this, let's say. What if we had a negative exponent here? Then it becomes a positive exponent if it's over 1. Do you see that? Do you see how that patterning works? All right, how about this one? 3 times 2 to the negative fourth power. Well, we can't multiply them because they're different bases, right? So we're going to treat them differently, but we can deal with 2 to the negative fourth power by rewriting it with a positive exponent. And we can rewrite it as a positive exponent by putting it in the denominator. And now we have 3 of these, so we could put 3 in the numerator. That would be a way to rewrite that problem in a different way. Oops, let's go here. So now we have a positive exponent in a denominator. What's another way we could write it? Well, we could write it with a negative exponent also, but we would just have to think about how to do that. So if it's positive in the denominator, then it is negative in the numerator, and vice versa. All right, what about this one? So here we have xy to the negative fourth power. The thing to remember here is that negative 4 power that exponent goes with the y, not the x, right? If it went with the x and the y, it would be in parentheses. But because there's no parentheses, it only goes with the y. So let's rewrite this part. Right now it's a negative exponent. We can make it positive by putting it in the denominator, y to the fourth, but that x is still there. So we're just going to leave it where it is, which was part of the numerator. Okay, so now I'm going to sort of show you a summary of all the properties we've been talking about. This is going to be a really great tool if you want to make a list of them in your notes, because these are all the properties that you'll be using, okay? So this is the multiplication property of exponents that says if you have the same base and you have a multiplication problem, that you add the exponents, okay? This is the product property of exponents that says you could have a product, 2 factors, x and y, that are both being raised to a given power. And that's the same as applying that pattern to each factor. So it's the product property of exponents. This is called power of a power. So this is the base is x to the b power, and it's being raised to the a power. And if you remember, we ended up repeating this factor this many times. So the result was that you multiply the 2 exponents with that base. And that's called power of a power. This is called the division property of exponents. And it says if we have the same base and we're in a division situation, that you could subtract the exponents to simplify it. Okay, division property of exponents. And this is the quotient property. So here we have a division problem that's being raised to a power, and we're going to apply that power to both the numerator and the denominator when we rewrite it. Okay, so now let's take a look at this problem. This is 19 squared divided by 19 to the 5th power. So we can apply the division of exponents property to this problem, and that would say that because our base is the same, that we can subtract the exponents. So if we have 2 and we subtract 5, then we have -3. So this is 19 to the -3rd power. Now let's think about why that is and what that means, okay? So I'm going to write this out in expanded form. So we have 2 19s in the numerator, and we have 19 as a factor 5 times in the denominator. And I'm looking for opportunities to simplify now. So remember, any 19 in the numerator can simplify with any 19 in the denominator. So those two simplify away. These two simplify away. And so now we just have 1 in the numerator, but we have 3 19s in the denominator. This is the same as 1 divided by 19 to the 3rd power. So typically we're going to only write answers with positive exponents, but we'll get to that later. Right now, you could write it either way, and it means the same thing. Okay, we're going to try one more problem, and I want you to do this with me. We're going to do it 2 different ways. So 2 to the 6th power divided by 2 to the -3rd power. So the first thing we're going to do is rewrite this problem as a division problem horizontally as opposed to vertically, and I think it'll make it a little bit clearer. All right, so we're going to rewrite this as 2 to the 6th power divided by 2 to the -3rd power. And that's how I read it. When I first gave you this problem, I read it exactly like this. Okay, so now let's think about division and how we like to think about division as the multiplying by the reciprocal. So we're going to do that. But before we do that, let's rewrite this as a positive exponent. So we know 2 to the -3rd power is the same as 1 divided by 2 to the 3rd power, right? It is a, that negative exponent tells you that it is, we're keeping that pattern of dividing by the base going. And so we could rewrite this quantity as a fraction. So now we have 2 to the 6th power, and I'm going to write that as a fraction, divided by 1 divided by 2 to the 3rd power. And whenever we have a division of a fraction, we turn it into multiplying its reciprocal. So we're going to leave 2 to the 6th power alone. We're going to turn that into multiplication, and we're going to do the reverse of this. So it would be 2 to the 3rd power over 1, which is the reciprocal. And so now we can multiply the numerators, which will give us 2 to the 9th power, and the denominator is 1. So this is equal to 2 to the 9th power. Okay, so that's using it as, thinking about it as division. Okay, we can also think about this as applying the rule of division of exponents, which says that when you have the bases that are the same, you can subtract the exponents. So we could do, this is equal to 2 to the 6 minus -3 exponent. 6 minus -3 is the same as 6 plus 3, which is 2 to the 9th power, because 6 plus 3 is 9. Okay, so you have some problems to try. Give it your best effort, and let's see how you do.